Hi again. Welcome to Lesson 4 on Designing Database Solutions with Microsoft SQL Server 2019. For today's topic, you are going to learn how to import records from an external CSV file to your existing database in SQL Server. You'll start working with the select statement in SQL and deal with the different ways of retrieving records from a database. To demonstrate these topics, I already created a database with the name MovieDB. This database has only one table named Movies. If we take a look at the table design, you'll see here 7 fields. The ID field, which is set to primary key and of type int. This is not set to auto-increment. We also have the title of the movie, then the rating, which is set to numeric with 1 decimal place. Sample values would be 1.0 up to 9.9, like in the IMDb rating. The genre, like comedy, action, animation, with max size up to 10 characters. Both the rating and genre allow nulls. Then, the length of the movie, like 2 hours and 30 minutes or 1 hour and 45 minutes. Its type is fixed char of size 5. Then, the release date of type date without the time component. And lastly, the rated as of type varchar 5. Values here would be PG-13, G, R, and so on. So initially, it has 2 records in it, the Lord of the Rings without rating yet, and the Matrix without defined genre yet. Though we can add records to it manually by typing here, you must know that SQL Server is capable of importing records from different external sources. It could be from another database, a spreadsheet like Excel, or from a flat file like plain text or CSV file. To demonstrate this, I have a CSV file or a comma-separated values that we can work with. This file is very common when you do importing and exporting of records because it's lightweight and almost all databases supported it. You can open it in any text editor like Notepad in Windows. Usually, the first row defines the field names or column names, then the succeeding rows are the records wherein each cell value is separated by comma. Like for example, the first record here is ID 2456 with title Johnny English. I'll close this and go back to the Management Studio. Now, if we want to import these records from a CSV file and append it to our existing table, what we have to do is to right-click on this MovieDB database, choose Task, and click Import Data. An import and export wizard will appear. Just click Next. In the Choose Data Source, you'll see different data source options like Excel and Microsoft Access, which may require additional driver components. But when importing CSV file, the one that you need to select is this flat file source. Then we are asked to browse for the location of our file. I stored it here in my sample CSV folder. By default, it is set to filter text files only. I'll change it to CSV files. Then select and open the movies.csv file. Additional information about the selected CSV file will appear. It says here in the format as delimited, which is good. This is the desired flat file formatting, although there are 2 other formats that are supported as well, such as fixed width and rugged right. The header row delimiter is set to CLRF, which stands for carriage return and line feed, which simply means set the cursor at the beginning of the line and proceed to the next line. Also, make sure that this checkbox is enabled if you have your field names or column names in the first data row. Then click Next. It gives us a preview of the rows that will be imported. Go ahead and click Next. Then in the Choose Destination option, you must choose SQL Server Native Client 11.0. And it will ask you for the server name. This is the same credentials that you use when you log into SQL Server. You can either use Windows Authentication or SQL Server Authentication. Then, in the target database, you can choose from any of the existing databases in your SQL Server instance, or you can create a new database where these records will be stored. I will not be creating a new one. What I want here is to append these flat file records to my existing database table that currently consists of only 2 records. So, I simply click Next, and in here, it asks me which table in the database I want these records to be stored. If you have other tables here, you may choose it, but I only have one and this is where I want my imported records to be added. In the Edit Table Mappings, The default option is to set the append rows to the destination table, but you can also change this to delete rows before inserting these records. This area is for you to double-check the source fields and the destination fields if they match. At the same time, you can also specify data type if you want to modify the previous design. It looks good to me, so I'll just click OK. You can also click the preview to see the first 200 rows that will be imported to this table. We only have 8 so far. I'll close this one and click Next. You'll also see here the conversion mapping with 2 options at the bottom. By default, it is set to fail. It simply means that any error that will occur when importing these records in this table, it will fail the entire import process, and changes will be reverted. And it's good. You may want to save it as an SSIS package or SQL Server Integration Service package, or simply run it immediately. I don't want to save it, I just click Next, and when I click Finish, the execution was successful. I'll close this one and go back to this Movies table and check its content. Very good. We have successfully imported 8 records to our Movies table. Here's the initial 2 records and the additional 8 imported records. If you don't want to append records to an existing table and what you want to do is to create a new table based on the imported flat file records, there is another way of doing this with less options and more direct to the point. To show you, I'll delete this Movies table. I've modified the CSV file that we have previously to include the first 2 records to make it 10 records all in all. Similarly, I'll right-click this MovieDB database and choose Task. Then instead of Import Data, I'll click this option Import Flat File. Now, it presented me with a different dialog window which looks modern than the previous one. I'll click Next, and then I'll browse for my movies.csv file. There are no other options here except to give the name to the new table where these records will be imported, as well as this schema drop-down list, which we don't have any aside from the default DBO. So just click Next and you'll see the preview of your data to be imported. Click Next, and in this phase, we can modify the columns if you want to before creating a new table Movies. So I'll set this as my primary key. I'll change the rating type to numeric 3, 1, then the genre to varchar 10, the movie length to only 5 characters, and in the release date, it's only of type date without time, and finally, the rated as is of type varchar 5. You can do this as long as you know your data. Be careful when changing this suggested data type. If you assign a type that cannot hold the data that will be imported, then your data will be truncated or cut. I'll click Next and then Finished. The operation succeeded. I'll click Close and go back to our movie database. I'll refresh the tables, and now we have a new table Movies, and if I edit it, you can see the 10 records were successfully imported. So now we can practice on retrieving records in our query editor window using the Transact-SQL select statement. I'll close this and click on this new query toolbar to open an empty query editor window. Also, make sure that this drop-down list of all the available databases for this current instance is pointing to this MovieDB database. Because if you don't change the setting here, the default database selected is master. And when you start executing queries against your movie database, you might wonder why it doesn't produce your expected result. Regardless of whether you selected the MovieDB or not, you can always include this SQL statement use to specify what database you're using. Then go and click Execute or F5 before writing the rest of your queries. This automatically selects this MovieDB in this drop-down list as well. So, the select Transact-SQL allows you to retrieve rows from the database and enables the selection for one or many rows or columns from one or several tables in SQL Server. The full syntax of the select statement is complex, but the main clauses can be summarized as this. Those with square brackets denote optional clause. So in short, the simplest form of select statement is just this select keyword followed by a select list. Let's have an example. I'll type here, working with SQL select, and when you place a double dash prior to any text here in your query, it will be treated as a comment and will not be executed. Notice that the text turned green. Let's say I want to retrieve the text hello. I can type select, then followed by the text hello. Character in SQL is denoted by a single quote. And when I click execute or F5, a result set window appears at the bottom of the screen with one row and one field containing a string hello as its cell value. I can do the same thing if I want to retrieve a number of say 1, 2, 3, 4, 5. I can write select 1, 2, 3, 4, 5, and when I click execute, all codes were executed, and you see both the result sets for hello and 1, 2, 3, 4, 5 appear. In your query editor, you can highlight the SQL codes that you only want to execute before clicking this execute button. If I want to execute this select 1, 2, 3, 4, 5, I'll highlight it and click execute, and you'll see the result 1, 2, 3, 4, 5. Transact-SQL is not case sensitive, and it doesn't require you to put semicolon at the end of each code. But for best practice, keep writing your SQL keywords in capital letters. So let's start using this select statement to retrieve all records from our table movies. I'll type select asterisk from, then the table name movies. Highlight it and execute. As you can see, all 10 records are retrieved. Select asterisk in SQL means select all columns or fields from the given table. Unlike with most programming languages that you probably encountered when writing application programs like C, Java, Python, and so on, SQL is a programming language that falls under declarative programming paradigm, which means when you write a program, you simply express what you want without actually describing its control flow. The database engine will do that for you. I'll copy and paste this code, and now, suppose you want to limit the fields that you want to retrieve. And most of the time, you don't want to retrieve more data than is needed because it is less efficient and consume more memory space in your application program. So instead of using asterisk, I'll specify here only the fields that I want to retrieve. Use comma if you specify multiple fields. It doesn't have to be in the same order as it is with your table. As you see, I placed the rated as field here prior to genre. Highlight it and execute, and the result set is now limited to only the ID, title, rating, rated as, and genre. SQL is also not sensitive in breaking line of codes into multiple lines. In fact, most SQL programmers write their codes into several lines because it is easy to read and easy to maintain. I'll duplicate this code, and as a good programming practice, I'll break it into several lines. Now, when separating multiple fields, you'll see programmers do this. The comma is placed prior to the field. Although it looks odd, but it has an obvious benefit. I'll execute it first for you to see that it still works. Aside from organization and readability, you can easily put a comment to any of these fields without breaking the entire code. So when I execute this one, rated as and genre are now excluded in the result set. However, take a look at what will happen if I put the comma after each field. I'll test it first to show you that it still works. And now, notice that when I commented out rated as and genre fields, the entire code breaks because I have an extra comma after this rating field. And for this to work, I have to delete this comma here. Although not a big deal, but as you go on writing and testing your query several times, adding and removing fields to be selected, you'll find this annoying and definitely time-consuming to add and delete comma from time to time. Unlike with the first code structure that I have shown you, where you can easily comment and uncomment any fields that you want. Another thing that you want to do when you have thousands of records in your table is to limit the number of records that is returned in your result set for you to work with. So I'll select all the fields from movies table, and then I'll use the where clause to limit the number of rows that will be returned. In here, you can use any relational operators to any field. For example, I only want the record where the ID field is equal to 2456. And sure, we only have one record that matches this condition because ID field is unique. I'll duplicate this code, and now I want to retrieve only the records that has a rating of above 8.5, and we can verify it. All 4 records that were returned has a rating of 8.6, 8.8, and 9.1 respectively. You can use any of these relational operators and make conditions to any of your fields like equal, greater than, less than, greater than or equal, less than or equal, not equal. You can use any of these two. Let's have another example. I want to retrieve the ID, title, rating, rated as, release date, and length. And notice here in the length field, it turned blue because it also has another meaning here in SQL. So if you want to be specific that this length is a field, you can enclose it in a square bracket. I'll execute this first, and it works. Let's return all records with rating less than or equal to 8.5. And we have 5 rows that match the condition. When you want multiple conditions for one or multiple fields, you can use the logical operators and, or, and not. I'll copy and paste this code again. Now, aside from limiting to only records with rating less than or equal to 8.5, I will limit it further to only the records with its field rated as equal to G. So, we have 2 records that will match this criteria. And when I execute, the result is Lion King and Monsters Inc., both rated as G and with rating 8.5 or below. You have to understand, the AND operator is restrictive. Both conditions must be satisfied. So, in effect, the result set is further reduced. Say, what if I want to retrieve all records with rating less than or equal to 8.5, but I don't want to include rated R movies? I'll duplicate this code again, and I'll change this condition that instead of saying equal to G, I'll say not equal to R. You can use any of these 2 operators, both have the same meaning. I'll execute, and I was able to retrieve what I want. Terminator 2 is no longer included in the result set. You can add multiple conditions by using logical operators. So when I say or rating greater than 9, it means that as long as the record has a rating of above 9.0, regardless of its other conditions, it will be included in the result. And when I execute, 2 records were added with a rating of 9.1, which is above 9.0. Let's try another condition. This time, I want to retrieve only the records where the movie length is 2 hours or more. Take note that since the length field is of type character 5, I have to enclose it in a single quote. You must know that even characters can be compared using the greater than or less than operators. It is their ASCII value, which is numeric in nature, that are the ones being compared. So when I execute this, only rows with length of 2 hours or more are returned. I'll add another logical OR, rating less than 8.0. So it means, regardless of the length, as long as the rating is below 8.0, it will be included in the list. Note that if you try to change this OR to AND, it becomes restrictive. And when we execute it, then no records were selected. It only means that there is no record with length of 2 hours or more, and at the same time, its rating is below 8.0. I'll paste the previous code again, and out of this result set, suppose we want to filter it further to return only the records wherein the rated as field is PG-13. And definitely, you might be tempted to put an AND operator here and say rated as equals PG-13. And when we execute this, the result doesn't make sense. Be careful when using logical OR and logical AND, as logical AND has higher order of precedence. In effect, this condition is performed first, before performing the logical OR operation. So it means, regardless of the result from the logical AND condition, as long as the movie length is greater than or equal to 2 hours will be returned. If you want this condition to be performed first before checking the rated as equals to PG-13 condition, then enclose this in a parenthesis. It guarantees that this OR condition will be performed first before this logical AND. And when I execute, the result set is what I expect. Since there will be fields in your table that sometimes allow nulls, the question is, how do you include or exclude records with nulls in your result set? I'll duplicate this code. And suppose I want to retrieve records where rating is null. When you use the equal operator and treat null as if it is a string, you will not get what you expect. You must understand that null is not a value. It is an absence of a value. So to test null in SQL, you must use the is operator. And I was able to retrieve only the records without any rating yet. On the other hand, you can negate this condition by inserting the not operator to simply say, retrieve all rows that has a rating and exclude those that don't have. And we no longer see the Lord of the Rings. I'll duplicate this code again and add a condition saying which of this record is rated as PG. And we only have one, John English. Let's have another example. I want to retrieve all PG-13 movies, but I don't want to include those without rating. Sometimes, you might want to retrieve records like similar to a search bar, wherein you just simply type the title, but when you use the equal operator, it only returns value if it finds an exact match. So, in this example, it has to be the exact title, the matrix. You can replace this equal operator with this like operator, and it will return the exact same result. The main difference is that you can use this %sign to replace any character or characters in your search value. So, in this example, it will return all records as long as it has the word matrix at the end of the title, regardless of the characters prior to it. I'll duplicate this code again and say, as long as it has the word king at the end of its title, and we have two rows, the return of the king and the lion king. You can also place it after a word, so this code simply means all titles that start with the word the, and we have 5 records. You can also place this %sign before and after the characters, so this condition means all titles that have characters li in the middle, and there you have it, English and lion. When presenting records to the end user, it is also important how data are sorted. So let's say I want all movie titles that are not rated R, and then to sort it, you use the clause order by, followed by the field you want to sort, in either ascending or descending. If you don't put the sort order, ascending is the default, and the result set is now sorted based on title in ascending order. To make it in descending order, just use DASC instead of ASC. You can also use other fields like, for example, order by rating in descending order. And we were able to retrieve non-rated R movie titles from highest to lowest rating. In addition to this, suppose we only want to retrieve non-rated R movie titles with the highest rating. By manually investigating, we have 2 records that match. And although we can force this to return a specific movie title by saying ID equals 7465, but obviously, this is not the best way to go because rating change over time. And if we have like 10,000 movie titles, we're not going to inspect it manually. Instead, we can simply put here top 1 and make sure that the rating is in descending order. When executed, it literally returns only 1 row. Though it's good, but it is actually unfair to the other movie titles that share the same rating. To include several records that fit the same criteria, even though we specify only top 1, we must include the with ties clause. And regardless of how many movie titles are there that share the same highest rating, all will be included in the result set. So, that's it. Even though there's more to learn in using the select statement, this basic knowledge is enough to get you started writing queries for your database table. Up next, we'll start creating multiple tables and understand the concept of database normalization. Again, thanks for watching. If you learned something of value here, please click the like and subscribe button for more programming tutorials. This is Joe Edgo and hope to see you in the next video lecture.